Hi, so today we're going to look at how to graph tangent graphs and cotangent graphs. So this is the function for tangent graphs. So we're still doing all the transformations. Now remember that the tangent and cotangent repeat after a period of pi units. That's the parent function. So the period, the way we're going to find it is going to be pi over b. And the period is always pi in this one. So it's different than the sine, the cosine, the cosecant, and the secant. So period is pi over b. Our subintervals, we're still going to find it the same way. We're going to get our period and we're going to divide it by 4. Now to find a full period, the easiest method is to find the first two consecutive asymptotes. So what you're going to do is you're going to get this object, which is a bx minus c, and set it equal to the parent function's asymptotes, which are negative pi over 2 and pi over 2. And then you're going to solve for x, and that's going to be your first two endpoints of your tick marks that you're going to make, which are going to be your asymptotes. Your midline is still going to be a k, and you're going to identify your a value. Now remember, the a value was our amplitude back with sine and cosine, but remember we also use that a when we were graphing the cosecant and the secant. Well, we're going to use this a as well, but it's not an amplitude, because remember that the tangent and cotangent have infinite number of solutions for the y value, for their output. So for example, if you have y is equal to tangent of 2x minus 2 pi minus 1, what you're going to do is you're going to find your period. It's going to be pi over your b value. Then you're going to get your subinterval, which is pi over 2 divided by 4. So we're going to keep, change, flip, which gives us pi over 8. Then we're going to find our consecutive vertical asymptote. We're going to get this object, which is 2x minus 2 pi equals to negative pi over 2, and we're also going to equal it to pi over 2. We're going to solve for x, so we add here 2 pi, divide by 2, so x is equal to 3 pi over 4. But your asymptotes, to make it easier, you want your subinterval and your asymptotes the same denominators. So if this is pi over 8, we would convert this one to 6 pi over 8 by multiplying the top and bottom by 2. On the other side, we're going to solve for x as well, do the same procedure. And then here, again, we need the same denominator, which is of 8 here. So we're going to multiply bottom, the numerator, and the denominator by 2. Now, we're not using the phase shift here because this is a lot easier to solve it using this method. So you're still going to find your midline, which was negative 1, and our a value is 1 here. So we're going to first put our tick marks starting on our first asymptote, which is positive 6 pi over 8, and then we add our subintervals. So 7 pi over 8, 8 pi over 8, 9 pi over 8, 10 pi over 8. Now the first number is your asymptote, and your last one is your asymptote. Your midline, you're going to put the dash. The middle tick mark will be on your midline. Tangent functions are increasing unless they're reflecting. So what you're going to do on your next tick mark is you're going to use the a value to go up 1 and then down 1. That way it's an increasing function, and remember that it goes towards the asymptotes. Now, the cotangent function is very similar. The only thing that's going to be different is finding your consecutive vertical asymptotes. So we're still going to find our period as pi over b, because the period for the parent function for tangent and cotangent is pi. Our subinterval, pi, the period divided by 4. But this time, to find the two consecutive vertical asymptotes, remember that in the parent function, cotangent of 0 and cotangent of pi are undefined, because that's our x over our y value, and our y value would be 0, so that's why it's undefined. So we're going to get the object, and again we're going to solve for x. We're going to still find our midline, and we're going to identify what our a is. So notice we're still doing the same thing for both here. The only difference is you're setting it 1 for the parent function for tangent, where the asymptotes are at, and 1 is for the cotangent. So in this equation, y is equal to 3 cotangent 2x plus 1. We're going to get the period, which is pi, divided by b. Our subinterval is our period divided by 4, so keep, change, flip, pi over 8. This time we're going to set this object, which 2x is equal to 0, 2x is equal to pi, and we're going to solve for x. And again, we want the denominators to be the same. So this is a 0, so it's okay, but this one, you want to convert it to 4 pi over 8. Your first tick mark is 0, and your last tick mark will be 4 pi over 8, which are going to be your asymptotes. So we're going to start at 0. Notice our midline was at 1, and our a value was 3. So we're going to start at 0, and we're going to add our subinterval, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. And our midline is at 1. Again, first one is your asymptote at 0. Your last one, the 4 pi over 8, is your second asymptote. Remember that this repeats. We're only getting one full period. Again, the middle tick mark is always on the midline. Cotangent functions are decreasing functions unless there's a reciprocal, and then you switch it. But in this case, there is no reflection, so this time from the midline, for this point here, from the midline, we're going to go up 3, and that's going to be our point, and we're getting that 3 from our a value. On the other one, we're going to go down 3 from the midline, so 1, 2, 3, and that's your other point. And then it looks like a curve that's going to the asymptote. So that's the way you graph tangent and cotangent graphs. Now make sure to finish your assignment, and if you need to practice more, make sure to go into the textbook.